Hey guys, welcome back to my YouTube channel. So in this video, I'm going to be doing an example of a independent random variables and their sums problem in probability. Bill and Gabby decide to meet each other at the mall. If each of them independently arrive at a time uniformly distributed between 7 a.m. and 8 a.m., find the probability that the first to arrive has to wait longer than 5 minutes. This is an example of a independent random variables and their sums. So let me write down the property for the independent random variables. This would be the probability that x is in A, also it's in B, is equal to the probability that x is in A times the probability that x is in B. If the random variables x and y are independent, if for any two sets of real numbers, A and B. And there's other important properties of independent random variables that I like to mention. One of them is the probability of x and y is equal to the probability that x times probability of y. This is a joint density function if x and y are independent discrete random variables with probability mass functions, probability of x and probability of y. So this is a independent random variables of discrete. And there's also a continuous one. So let me write down the continuous. Let's denote f of xy is equal to f of x times f of y. If x and y are independent continuous random variables with density functions f of x and f of y, it's a joint density function of a continuous independent random variables. If we let x and y denote the time past 8 that Bill and Gabby arrive, then x and y are independent random variables, each of which is uniformly distributed over 0 to 60. So the probability would be x plus 5 is less than y plus the probability that y plus 5 is less than x is equal to 2 times the probability that x plus 5 is less than y, which is just the symmetry of that. So it would be written as 2 times the probability of x plus y is less than y is equal to 2 times the integral of x plus 5 less than y of f of x y dx dy. So let me set up the integral. So it would be 2 times the integral of 5 to 60. We have 0 to y minus 5 of 1 over 60 squared dx dy. And the first thing I like to do is I like to take out this 1 over 60 to make it easier. So that would be 2 over 60 squared times 1 squared over the integral of 5 to 60, 0 to y minus 5 dx dy. And the first step I like to do is I like to work with the x's, in other words the dx. So 0 to y minus 5 of dx. And we see we have a nothing, or 0. But what's the antiderivative of 0? Antiderivative of 0 is just a constant. So therefore, the antiderivative of a constant is just x. And if we subtract these two, we just get y minus 5 minus 0 is just y minus 5. Now let me work with the y's integrals, or in other words, dy. So let's do 5 over 60 of y minus 5 dy. I'll take the integral of y minus 5. It's just y squared over 2 minus 5y. I'll just plug in 60 here. And we get 1500. Let's plug in the 5. And we get negative 12.5. So 1500 minus negative 12.5 is just 1512 times 0.5. We can't forget about the outside numbers. We got 2 over 60 squared, which is really just 2 times 3600 times whatever that is, 1512.5. And if I simplify this, this would be 121 over 144. So the probability that the first to arrive, which has to wait longer than 5 minutes, is 121 over 144. And this is an example of an independent random variables and their sums problem in probability.